today supposed to be?
Oh, yeah. Are we starting any chapters soon?
No, I'm just adjusting my pants. I don't want to do that on camera. Okay.
Wait, what's the date today?
That was the 8th. No, it's the 13th. It's not the 18th.
So we're supposed to do, quote, more factoring. So is that why you're saying it might be?
No, I combined that. We were a day behind.
Oh, we were?
Yeah, because at one point I had scheduled for us to do 2 things in one day, but that wasn't going to work.
Oh,
Okay.
I was going to say something, but I forgot.
Where would you guys like to begin?
Can we start with the,
Wait, was my
it's
name
like
on the
74 to
second page
79,
of mine?
that little section?
74 to 79? Pick one.
Is it cheating if I look up
wait,
the
the hardest
factors
one, so I can
on,
do
like,
these. 77.
findthefactors.com?
Yeah.
That's cheating?
Yeah.
Like, what's cheating? Huh? Looking at, like, the factors on findthefactors.com for, like, 1,000.
Funfactors.com.
Okay. So you want to do 74? Is that what you said?
77. Like, do a hard one so I can do
So, okay. Number 77. 2y squared. 2y squared minus 4y minus 8 equals negative y squared plus y. Okay.
We got confused on these at first, and then I got them.
So the idea is that we're going to want to get everything to one side so that it equals 0. Because you remember you can use the zero product property to solve. So we're going to be adding this and subtracting this. Adding this and subtracting this. So you have 3y squared minus 5y minus 8 equals 0. At this point, we can just go straight into factoring. We're going to take our 3 and multiply it times our 8, get 24. So, but it's negative. What?
No, she was just saying that.
Oh. And then, so we're looking for 2 numbers that multiply to negative 4 but add to negative 5. Well, we don't have to look very far. It's going to be 3 and 8. So negative 8 and positive 3. Does this make sense so far? Am I going too fast or do you get it?
Yeah, I can do it.
Okay. So then 3y squared minus 8y plus 3y minus 8. And does it feel hot in here again?
A little bit, yeah.
I have a sweatshirt on.
I don't understand why it doesn't work.
I think it's fine.
Yeah.
It's like it won't go down anymore and it won't come on. I don't know.
I guess we can ask.
I would rather lay low, personally. Okay, so there's going to be a y. That's really all you can factor out from here. And that becomes 3y minus 8. And then plus 1, because this is 3y minus 8 already. So we do that plus 1 here so that we'll have that second term to pull into our binomial equals 0. So you get y plus 1 times 3y minus 8 equals 0.
Wait, how'd you get that?
How did I get what?
Y plus 1.
So I'm factoring out the 3y plus 8, right? Even if I didn't have a 1 right here, if I factored out 3y plus 8 minus 8 from this side, I would get 1 because I'm dividing it by itself.
Okay, so that stays the same.
Yes.
And
Y
you just did that.
plus 1 took the remainder.
Oh, okay. Oh, I see.
Okay. So
That's what I did wrong.
now I'm going to set each one of those equal to 0. So here y equals negative 1. And then here, so y equals 8/3. So those are your 2 answers. Homework? Thank you. Okay.
Oh, can you check really quick if the second page of that first one that I handed? Can you just make sure I have all my name on all of it? Because I think it might be missing one here.
Did anybody else put those words
Nope.
Nope.
Okay, so which one would you like me to do next?
We start with 90. Actually, no. We start with I feel like it'd be easier if we just stayed up for lunch.
I can't help you guys during lunch today because I have to work on grading my calculus papers. So you guys can say if you want to, but I can't. Okay.
I don't know what you got. Why don't you try to do that?
So what do you want me to do?
Because I know
89.
89. Okay. Is there a formula for factoring the sum of two squares? So, yes, but you haven't learned it yet. Consider the sum of squares x squared plus 9. If this sum, which means at this point you'd be obligated to say no.
Yeah.
Right. If this sum can be factored, then there are two integers m and n such that x squared plus 9 equals x plus n times x plus n. Write two equations relating the sum and the product of m and n to the coefficients in x squared plus 9. So, it would have to be mn equals 9 and m plus n equals 0. Because they're asking for two equations relating the sum and product. Here's the sum of m and n. Here's the product of m and n. And we're relating it to x squared plus 9. So you know it needs to multiply to the last one, but it needs to add to the middle one. Since the middle one's not there, it must add to 0.
Oh, okay.
Does that make sense? Yeah. So that's A. B shows that there are no integers m and n that satisfy both equations you wrote in part A. I don't know how they want you to show that, because they both have to be the same sign to multiply to be a positive.
What?
So they can't add to 0 unless they're each 0, but then that would make this one not true.
So what should we
Say, this part is dumb.
Okay.
This is logical. They both have the same sign, thus they cannot add to 0. Unless they're both 0, in which case they cannot multiply to 9.
I just said like for any value of m or n, there can only be one equation that it'll equal. So it can't equal both of them.
Okay. That sounds very fancy. Okay, so then do you want me to do 91 or are you good?
Yes.
Okay, a high school wants to double the size of its parking lot by expanding the existing lot as shown. By what distance x should the lot be expanded? Okay.
Sorry. 91.
Wow, I can even see the light green. Awesome. Okay. Old school, so 165. $300. Oh, let me erase that so I can. So here's the old lot. Here's the expanded. Okay. X. 75 and 75. Okay. By what distance x should the lot be expanded? Oh, it wants to double it. Okay. So if the old lot is 75 plus 165, that's how long this side is, times 300 plus 75 minus 300 times 165. So 375 times 240, 9,000 minus 49,500 equals 40,500. Oh, I'm adding extra zeros. Or not adding enough. Okay. So This is the size of the old parking lot. It wants to double it, which is going to become 81,000. So 81,000 must be equal to, let's see, x plus 75 plus 165, which is 240, times x plus 375, and then minus the 165 times the 300, which was 49,500. Does everybody understand where I got everything?
Mhm.
Tori, does it make sense? Okay. Listen to that tick.
It's like a real classroom.
Straight up. Just wait. Okay, so then we're going to have, if we FOIL this out, 81,000 equals x squared plus 375x plus 240x plus, what's 240 times 375? 90,000?
Just a little bit of that mental math there.
I already did it in this problem. I'm not that quick.
Or just take a picture.
Sure. It's also, on YouTube.
Oh, did
But I
you
wanna
already
get it
go
done
through
for
all the
today, so it's
homework
cool.
on YouTube?
What?
Did you already go through all the homework on YouTube?
No, I'm broadcasting to YouTube right now.
Oh,
Gosh, I don't have time to do that.
okay.
Ain't nobody got time for that.
Because you gotta do it and grade it.
Yeah.
Like 5 times through.
Well, I don't do it anymore because I don't want to.
I mean, you didn't. I said, I meant that you would have to do it.
Oh, yeah. Okay. So at this point, I'm going to combine 90,000 and negative 49,500, which gives me 40,500. And then I'm going to subtract 40,500 minus 81,000. Negative 40. Oh, that's obvious. 0 equals x squared plus 375 plus 240 is 615, I think. 615x minus 40,500. Now I just need to factor it. That's it.
Looks like a period factor.
Yeah, it does. Doesn't it?
I didn't get this far.
How many factors of 40,500 are there?
Beats me. I don't have any idea.
You could run it through one of those websites and actually.
You know what I'm saying?
No, we can do it. 40,500. So we've got 1 and 40,500. They're not going to be anywhere near what we need it to be. So let's take out 100. And that gives us 405. And so we know that one of them is negative because this is negative. So if we subtract, that gives us negative 305. We're not very close. So let's take out 50. So I just get a text message. No. There's somebody else. Or maybe I did. Yeah, 1044. Okay. So if we take out 50, then we get 810. And that subtracts to 760. Getting closer. So I wonder if we can take out 75. Yep. So we have 540 and 75. Those subtract to not the right number, drat. 465 Man, this is taking forever.
When in the real world will you actually have
Oh,
to
I see. Never mind. I was like, wait a second, why do we have to see that?
Just got
Negative 40,000.
You just
to?
Okay, it's 675 and 60.
So it's negative 40,000.
675 and 60. There you go.
Yay!
Yay! So 0 equals x plus 675. The bigger one must be positive because the difference is positive. And x minus 60. So we know we're not going to be increasing by a negative number, which is what we'll get if we do x plus 675 equals 0. So we're only going to do the other one. X equals 60. Has anybody seen Horton Hears a Who?
Yes.
I read the
Love
book.
that movie.
I read the book. Just reminds me of Vlad. Easy peasy.
Oh my gosh, Katie in the movie, like the little one. I love her so much.
We should just take a class period and watch that.
I watched tons of movies in my calc class. We just finished Hunt for the Wilder People and started Hot Rod.
Oh, Hot Rod is a good one.
Yeah, it is.
Wait, what?
Whiskey.
No.
Why? Because we can.
But like, how do you have time to do that?
Because we'll, you know, they're in calculus at this point, so it's pretty.
Can we do that?
If you get through the material fast enough. Like,
Probably won't have
No more questions.
no more questions. That's not true. Lots of questions. Anybody have any more questions about this one? Everybody's good? Okay. Can I erase it?
And lots of questions on this section.
Any more homework problem questions?
Yeah.
Okay.
5, 97, 99, 100.
Can I do them really fast?
Are any of those ones where it's like it doesn't have the third part of the polynomial
Wait, I tried to do
or
extra.
of the
Those are a
quadratic?
pain.
Like it doesn't have plus or minus anything at the end.
You mean,
I just picked one.
okay,
So it's just like
x squared plus 4x.
Like, I get that.
yeah.
If you do that, then
something
it's gonna
like
be
that.
like a square, right?
Then you factor out an x, and you're left with x times 4 minus, or x minus 4. So x must be 0 or positive 4.
There was one that I couldn't get into factor, like I couldn't get it factored down. Can I look at my homework actually?
Then
Yeah.
it probably can't be factored.
Okay.
There's like ones where it's
So wait,
just
which was the
cannot.
next word problem you wanted me to do?
93.
93.
Yep.
Find the value of x. Really? X times 2x plus 1 equals 105.
I did this one like multiple
Because we're
times.
multiplying the dimensions of the rectangle together. X, 2x plus 1, and we know that it equals 105 because it tells us. So, 2x squared plus x, subtracting this, minus 105 equals 0. Factoring 2 times 105, which is negative 210, and adds up to 1. So, negative 210. If I factor out, let's see, factor out a 10, that gives me 21. That adds to negative 11. That's not right. So, does 11 go into this number? No. 12 go into this number. 15 and 14. So you get 15 and 14 multiply to 210, add to positive 1. So positive 15, negative 14. So 2x squared plus 15x minus 14x minus 105 equals 0. So factor out an x because that's the GCF from this side. And you get 2x plus 15. I already know I'm going to need to factor out whatever makes this a 2. So minus 7x, or 7, gives me 2x plus 15 equals 0. X minus 7, 2x plus 15 equals 0. Setting each one equal to 0, I get that x equals 7 and negative 15 over 2. for multiplying 2 times 105 to factor.
Do you just multiply by 105? Or do I multiply
Right,
by-
I'm only multiplying the first term times this one so that I can get these two
Okay.
numbers, and then I'm splitting it up.
So for some reason, number 79, page 260,
Okay.
was being really weird for me.
Okay.
I don't know what was happening. I must have just like really high.
Maybe don't mention that at a Christian school in front of
I'm
your
not-
teacher.
Okay.
Anybody else
I
need
mean,
this?
in case nobody
Start
caught
popping it down.
on to that was a massive joke.
Big disclaimer.
Here, I'll leave that up for a second. I have so many markers.
What was the joke? Was it funny?
No. Okay, 79.
That is not gonna be funny.
W plus 6 squared equals 3 times W plus 12 minus W squared. Okay, so
Yeah.
if I FOIL this one out, I'm going to get W squared plus 12W plus 36 equals 3W plus 36 minus W squared. Add W squared, 2W squared, subtract 3W plus 9W, subtract 36 equals 0. Factor out a W, 2W plus 9 equals 0. Set each quantity equal to 0, W equals 0, and negative 9 over 2.
Okay, so I was right. I did get the right answer, but I didn't put the W equals 0 and negative 9 over 2. But I did get it factored down to that last point.
Good for you.
So.
Yeah, I wrote that down because I did that wrong and I didn't even know it.
I was so confused because I'm like, isn't it supposed to be in 2 bubbles?
Oh, well, you can think of it as like W plus 0 if you need to for the second binomial bubble. Okay,
Oh, I guess, yeah.
which problem next?
That's why it equals 0. I just got that. Okay.
Good.
I don't know why that took me so long.
I'm glad you got it.
I'm just writing something. I don't even know.
You want me to do the next word problem?
Yeah.
Okay.
That
I don't even remember what your assignment was, so. Well, I'm not going to erase that yet. 95? Let's use a blue. 95, area of a trapezoid. X. 2x minus 1. 4x plus 3. Area equals, and if you guys don't remember the formulas for the areas, they're in the back of your book. Okay, so 114 equals, my area is going to be 1/2 times my height times 2x minus 1 plus 4x plus 3. So 114 equals x over 2 times 2x plus 4x is 6x, negative 1 plus 3 is 2, equals, and then I'm going to have blah, 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 factoring this in. I'm going to get 3x squared, or not factoring, but foiling. 3x squared, and then I'm going to get plus x, and then 3x squared plus x, subtracting this to the other side, minus 114 equals 0. Multiplying 3 times negative 114, I get negative 352, adds to 1. So, well, I know 11 goes into it. So, 352, and so 11 goes into it 32 times. Does 12 go into it? I don't know. I don't think so. I know 14 goes into it. Let's see. Or maybe it doesn't. It doesn't. 352 divided by, getting closer, 16 and 22. Ooh. Did I make a mistake? Does anybody see a mistake?
I was just writing things down as quickly as possible. Yeah, let's just do it.
Isn't it supposed to be negative 2?
Where?
6x minus 2?
Well, it was 4x plus 3 and 2x minus 1. So negative 1 and positive 3 end up being positive 2.
So
3x.
Looks right.
I agree.
Not solvable, or is it not more closer?
There's so many things in like the calculus one that my mom just said, okay, the book is wrong. The book is wrong. What is it, 340?
what's the answer?
I don't know yet.
I had a tutor, the same tutor for Algebra 1 and Geometry, and there was so many things where the A to G flips messed up.
Yeah, this one's weird.
342, not 252.
You're right.
Good job, Tori.
Congratulations.
Okay.
You're smart. That's a funny joke. Now you're being hurt. That's okay. Standard.
You might not mean it to everyone though.
No, you are. Yeah.
It's only fair.
I don't think this is factorable.
That's because what's wrong with you, right? Jacob hasn't said anything.
Why do you look so uncomfortable right now? You're just like, I'm not.
Okay.
I'm tired.
So then if you graph it, you get that x equals 6
Okay.
and some negative number. So x equals 6.
So
Okay.
we went over that one.
All right, which one next?
97. No. Wait. I mean, there's tons more.
Wait, not 97?
97, yeah.
Okay.
I got 12.5. They're like, no, it's 2.5. I'm like, no! I'm
Okay.
yelling at the book, but, you know.
97. As part of Black History Month in February, an artist is creating a mural inside of a building, a painting of dark, surrounded by a border of uniform width.
It's fine.
But you can't erase them.
Okay. The side of the building is 50 feet wide by 30 feet high.
What? Stop fucking with me. She said pens are better.
And the artist wants to devote 25% of the available space to the border. So, however long this is. Oh, that's dumb. Okay. If this is 4x, then this is x. Lengthwise. X. No, that doesn't work either. If this were 8x, then this could be x and this could be x. This problem's dumb.
You just like
25% of the available space to the border.
Call it unnecessary.
Hang on, let's do it this way instead.
Instantly triggered.
This is x and this is y. Okay. That means that's also y. So,
at least we're getting over your perfection.
4y equals x, and then x times y, or 50 minus x, times 30, let's see here, minus y, okay, 50 minus x, hang on,
Wait. You're just taking all these numbers from the dimensions that like they already gave us, right?
yeah.
Okay.
Move on to the next line.
Ugh, I don't want to have to think about how to figure this one out. I wish they didn't do that 25% thing. Okay. I'm gonna start over. Okay.
No, just like take away the food.
This is 50. This is 30.
Oh, wait, this is pointless.
Oh, yeah, I'm starting over.
Making sure
Okay.
Oh no.
So total area is going to be 1,500. Okay. Call this X. So 1,500 minus, okay, if this is X, that means, all right, let's call instead this X, and this is X. That means that inside, this is 50 minus X. This is, or 50 minus 2X, because there's two X's. And this one is 30 minus 2X.
Oh my goodness.
So,
Okay.
so if I multiply the whole thing,
Oh.
I'm going to get 1,500. So 1,500 and then is 4 times as big as 30 minus 2X times 50 minus 2X.
Wow, I would have never gotten that.
Because this has to be, this is 25% of the total area, which means it's 1/4 of it. So to make them equal, I need to multiply it by 4. So then 1,500 equals, okay, let's do this. Let's factor out a 2 of each one of these so that this becomes 8, because I factored out a 2 and a 2. So 4 times 2 times 2 is 8. This became 15. That's just X, and then 25 minus X. Okay, now when I multiply them together, got my 8 out front. 15 times 25, I don't know, 15 times 25, well, 5 squared is 625 minus 50 is 425? 375. 375 minus 15x minus 25x minus x squared, or it became plus x squared. Divide both sides by 8. Does 8 go into 1,500 evenly? No, of course it doesn't. So divide that by 2, and it's going to give me 750 over 2. Oh, over 4. So 375 over 2. Equals x squared minus 40x plus 375. Why do they give you these problems that are not factorable? 0 equals x squared minus 40x plus 375 over 2. So I'm going to need to multiply everything by 2. So that 0 equals x squared minus 80x plus 2x squared minus 80x plus 375. I'm factoring 375 to find which two factors are negative 80 apart. But it's actually going to be adding because this is positive, so they have to have the same sign. They're both negative. So start with a small number. It's 375 divided by 25. 15. 375 divided by it's 5 and 75. So, oh, oops. I'm not factoring that. I'm factoring 750. 750 and adds to negative 80. So That's negative 80. Why do they give you ones that aren't factorable?
They just don't like us. Well, they don't like anybody. People who write these are like the children of people who write the SAT. They're not quite there, but
And my cousin was supposed to write the PSAT.
I like taking the SAT.
it's so weird because the math is, it's not like very much what.
This is super dumb. So they give two possible answers. One's in between 34 and 35, and the other one's in between 6 and 7. So I'll accept any of that for this. Just write. You said you would accept. Okay. All right. Which one next?
6 and 7 what feet?
It's in between 66 and 67, or in between 6 and 7, and in between 34 and 35. So I'll accept either. And I really do forget, because there have been a couple of times when I've been grading your homework and I've seen somebody write, "You said I could do this." I was like, "Oh, I guess I must have."
Put that on all the top.
Nice. Man, you're on a moral roll today.
Yeah.
Okay. Any others?
I think we should get to the new stuff so we don't.
Oh yeah.
Okay.
We're like 3/4 of the way done with the class already. We're like at 40 minutes left. What?
I don't want to rush through it.
4
I
minutes?
still have a lot
40.
left, but
No, 40.
You guys can have an extension on the homework if you need it.
99 to 101.
Use the restroom.
Yeah, I don't know where it is, but
Does
good luck.
anyone have work
Closest one is by
after
history.
class? Cause like I feel like I want these, but is it worth it? Is my real question.
Exactly.
Up to you
You wanna
guys.
take one?
Is that worth it?
Yes, I do.
I want to keep my grade because I actually like my grade. I don't know how I have that grade, but I like it. You always have like the good stuff.
Oh, it's so like pastel and like aesthetic and then like
Thanks.
I don't get it. Taste.
No.
Oh,
It's like too big.
just go faster. Just go.
What's it called again?
Oh, is it out?
What?
Is it out?
No.
You sure?
Yes. I just loaded it.
Yeah, just take
The thing about cute stuff is a lot of it doesn't function as well.
Well, it's not the stapler, it's the pink staples I have in there.
Pink staple.
Yeah, I have pink staples.
Dude, wow.
It's not gonna work. Wait.
Look at this.
Easy. How thick is this?
It's like 20 pages maybe?
Just like 20 pages.
It worked out.
That's not bad. 20 pages of paper.
Thank you.
And sadness. And stress. I was filing for my homework.
We're just gonna
and like organizing it. And then I was like,
staple it one at a time.
it's like 1,000 pieces of paper of literally pure depression on a page. This is what I've been wasting
Heavens
my
to
life
Betsy.
on. This is who I am now. Let me do that. Oh my goodness.
That
Me
sounds
too.
wonderful.
Knowing how easy this class is compared to what the rest of your life's gonna be like, it's like I wanna have.
It's not really this class that's so hard. It's just that I have a lot of other stuff and I generally put this one off the most, which isn't good. I'm trying to prioritize this one, but it's like
This one.
psychology takes
There you
so
go.
long.
I got it.
This class. I'm
Okay.
taking 9 classes, and this one's top priority right now, and I'm still not.
You say this one is
Well,
like
5-3 should be simpler.
third or fourth.
Simpler than 5-2.
Honestly, please.
Okay.
So tired.
Don't stay here with my teeth.
You need to push the staples up or it won't work.
Editing
I didn't do that just then because I didn't know somebody else was going to use it. So just open it and push the staples forward. Just pull up the pink part. There you go. And then be careful that you push it back all the way. Alt.
Back or forward?
Yeah, push it forward a little bit.
Have you never used a stapler?
Is this newfound technology
No,
for you?
Mine has like a button that you press and then it'll just push forward.
Oh,
I smushed my hand in the stapler when I was really little.
I stapled my thumb. It's not working.
You guys
I
should
did that
really
while
just
hanging
start
Christmas
using
lights.
crimpers. Can we make those popular in the U.S.?
I'm just going to go ahead and get started with the lesson. Okay, so here's the rule.
Bruh.
You know what? Dog ears will work for me.
I told you. Don't treat me like I'm dumb.
I'm not. I'm kidding.
Here you go.
Yes, treat me like I'm dumb.
Here's the lesson.
Oh,
This is important.
There was one that was stuck in it.
There was a little
Straggler.
Is that homework?
Thank you.
No, maybe I
You haven't even had your milkshake yet.
Okay.
don't have a milkshake anymore.
So, solving by square roots. A little review of roots. If you have the square root of a product, you can split them up. So, if you have the square root of 12, you can recognize that that's the same thing as the square root of 4 times 3. Square root of 4 times the square root of 3, which is 2 rad 3.
Oh, what?
Mucho importante.
Wait.
Sorry.
Yes.
Wait, is it?
Yes. Okay, I got it.
Okay, good. So if you have the square root of 500, you would recognize that's the same thing as the square root of 100 times 5. Square root of 100, square root of 5, 10 rad 5. Or if you have the square root of 6 over 4, that's the same thing as the square root of 6 over the square root of 4, which is the square root of 6 over 2.
Could you also just simplify the fraction in the like 6 equals 3? Why is this reminding me?
If you did, you would have the square root of 2 in the bottom, which you cannot have. So if you have the square root of 50 over the square root of 2, you can extend the radicand or radical to include the radicand, and then that becomes the square root of 25, which is 5. So sometimes it's better to simplify before you take the square root. You will just have to become very familiar with working with these numbers. Does this all make sense?
Yeah.
Now, I've been doing this for a very long time. I don't expect you to be as quick as I am. That's what the whole lesson's on. Okay? So the idea is when you look at a number, you need to be able to factor it in your head or on paper, whatever works for you. Try to find if there's a perfect square that goes into this number, to either one of these, or then either one of these. You're going to try all kinds of things that you can to try to see that. So the perfect squares are things like 4, 9, 25. I skipped 16. 16, 25. Okay? So try immediately dividing the numbers that you know are perfect squares into this, what's called a radicand. This symbol is a radical, and what's underneath it is called a radicand. Everybody's good so far? Okay. So, simple rule, but without calculus, you cannot do a square root by hand. So I'm not going to teach you the calculus necessary right now to do that. The moral of that story is, before calculus was derived, to find, or even afterwards, before we had the calculators, to find these square roots, people would have to do immense amounts of math. So they started printing tables in the back of the books and about like all the different square roots estimated out to such and such decimal point. Well, it's really, really difficult to divide by a large number. Have you guys ever noticed that?
Yeah.
Yes. So what they did was a bunch of old male mathematicians said, okay, you can no longer have the square root in a denominator. That's bad. So now what you need to do, like say you have 1 over the square root of 2. You cannot have the square root of 2 in the denominator. That's the rule. You have to do what's called rationalizing the denominator. Because you have to put this into a rational number. So how do I get rid of the square root? What can I multiply? Remember, my rules are that I can multiply or divide by anything as long as that thing is equal to 1. So I can multiply the top and the bottom by the same thing, and it will still be equal to the same number. I'm going to do that. It's the identity property that we talked about before.
Well, you would multiply by 2, right?
If I multiplied it by 2, it couldn't come under the radical, unless it came under the radical as a square root of 4.
Or no, you would, you'd have to square everything on the top and bottom, right?
But I can't do that because it won't be equal.
So could you just, so like once you multiply it and then do square root of 2 over square root of 4, so could you just say that's equal? Or no?
Oh.
Okay, the square root of 2 is saying what number multiplied times itself is 2.
Wait.
The square root of 2. So if I take the square root of 2 and multiply it times itself, what do I get? 2. If I take the square root of anything and multiply it times itself, I'm going to get just the radicand. Does that make sense?
Mhm.
What's the square root of 7 times the square root of 7? What's the square root of 100 times the square root of 100? What's the square root of x times the square root of x? Does this make sense? Okay, so every time that you have this in the denominator, you have to multiply the top and the bottom times that thing to get rid of this. Does that make sense? So like going earlier when she asked, couldn't I just simplify this beforehand? If I had the square root of 6 over 4 and simplified that to the square root of 3 over 2. You could, but then you would have the square root of 3 over the square root of 2. So I would need to multiply the top and the bottom times the square root of 2 because I can't have a radical in the denominator. I can extend this radical over both of them to be 3 times 2, which is 6. Square root of 2 times the square root of 2 is still just 2. So I'll get the same answer. It's just more steps. Does this make sense?
In the other example with the square root of 2,
Uh-huh.
could you just do the square root of 2 over square root of 4 and then that equals half?
It doesn't equal half. The square root of 2 over the square root of 4 is equal to the square root of 1 over 2. The square root of, because if you had the square root of 2 over 4, like from here, that would be equal to the square root of 1 over 2, which is back where we started.
Oh.
Because that's equal to the square root of 1 over the square root of 2, which is 1 over rad 2, and I'm still stuck with a radical in the bottom.
Okay, so it's still equal, it's just anticipated.
Right, all of those things are equal to each other. There's only one that was considered okay, and that's this right here, because there's no radical in the bottom. Does this make sense?
Wait, so even if you didn't have one specifically in the numerator, you can still multiply it by any square root, right?
Absolutely. I can.
Just as long as it's not in the denominator.
Right. Does anybody have any questions about this before I erase it? Is anybody still copying it down? Okay. So I'm going to show you. Okay. So like number 36 says to simplify the expression, and it's a square root of 4 over 49, which is the same thing as the square root of 4 over the square root of 49. Square root of 4 is 2, square root of 49 is 7. Does that make sense?
Yeah.
Okay. So, 45. Still same instructions, simplified the expression. The square root of 6 over 5 is the same thing as the square root of 6 over the square root of 5, but I can't have a radical in the denominator. So what do I need to do next?
Multiply by the denominator.
That's right. This is the same thing as the square root of 6 times the square root of 5 over 5, which is the square root of 6 times 5 over 5, which is the square root of 30 over 5. And don't get confused. Just because 5 goes into 30, this 30 is under a radical. It's not 30. It's the square root of 30. And we don't know what that is. So don't simplify from here. This is done. Okay? It's going to be tempting, like when you have this kind of a thing. You see 2's, you want to cancel them out, but you can't. The order of operations says you have to simplify this part first before you can divide. And this 2 does not go into this one. So that's simplified. It'll be tempting, but you can't do it because that 30 is the square root of 30.
Wait, can you simplify if the denominator is also radical?
Yes.
Like if they're both radical and they both factor?
Yes. If you had this, which is a completely different number, that would be equal to the square root
Is that the
of
same
6.
as if you write it with each number having an individual radical sign in the numerator?
You mean like right here?
Yes, like the square root of 6 over square root of 5. That's the same thing. That's the square root of 30 over square root of 5.
This is totally different from the problem we just did. This is just explaining that if you are able to simplify while they're both under the radical, you can. But they have to both be under the radical. You can't just decide to put one under the radical.
Wait, you can't have each one under its own radical and then simplify?
You can bring them under the same one if they're each under 1.
Okay.
Like right here, they're each under 1. So I brought them under the same one. But you cannot combine numbers that are not under a radical with numbers that are. 5 is not the square root of 5 there, just 5. It's not a like term with the square root of 30. Does that make sense? Okay.
Do we have any class on Monday?
Yep.
I'm not going to be here.
Okay, I'll try to put it on YouTube so you can do the homework still.
I'm going to be in Mexico.
Okay.
I'll try.
All right, and then like say number 50. You have the square root of 15 over 7 times the square root of 4 over 3. Now, I can bring them under the same radical just like I did here. The square root of 15 times 4 over 7 times 3. Then I can cancel these out and get 5 right there. So now I have the square root of 5 times 4 over the square root of 7. I'm going to separate everything. Square root of 5, square root of 4, square root of 7. Equals, square root of 4 is 2. So I can just write it like that. But I can't have this rad 7 in the denominator. So I need to multiply the top and the bottom by rad 7. Which is going to give me 2 times the square root of 5 times the square root of 7 over 7, which equals 2 times the square root of 5 times 7 over 7, which equals 2 rad 35 over 7. Now you do not need to write out each individual step. If you don't have to do this kind of stuff, or the only difference is combining it under one radical, you don't have to. But if you're struggling with knowing what to do next, I highly recommend that you do that to build that comprehension pattern. Does this make sense?
I'm a little confused about where we got the 2 from. Oh, square root of 4, okay.
Right. Now, Like, let's do number 25. The square root of 98. So, I don't know what the square root of 98 is, but if I can take the square root of part of it, it's like simplifying a fraction. Okay, like if I have 4 over 8, 8 does not divide into 4 evenly, but I can recognize that there is a number that I can divide out of each one of these, and I can actually do that division. So I can do 4 times 1 over 4 times 2, and I can divide 4 into 4, it'll just give me 1. So yes, I'm factoring to simplify. So that's what I'm going to do here. I'm going to factor to simplify. So I'm going to say, okay, what are my perfect squares? Because if I can find a perfect square under there, I can take the square root of that. So there are 4. I'm going to look at 4 and 16 because those are even numbers. This is even. Does that make sense? So there's no point in looking in like 9 or 25. They're not going to go into here perfectly. Okay. So I don't know what 98 divided by 16 is off the top of my head. I don't think it's even though. Let's see. It's not. So 98 divided by 4. Ooh. Really? It's just the square root of 98? Yeah. Oh. 2 times 49. Oh. Does that make sense? What would be next, Tori? Yeah. Like this. Can I simplify either one of those?
Yeah, 49%.
There you go. So now we're going to apply this to quadratics. It's not that bad. I promise. It's like one example's worth. What?
Are we doing 5.42?
No, just 5.3. Okay. Does anybody need any of this still? Okay. Okay. So, looking at like number 61. Says 4 times x plus 1 squared equals 100. Okay. So, I need to get this x by itself. That's my goal. So I'm going to try to get rid of everything over here with the x. Well, when you're simplifying, you go PEMDAS, right? Order of operations. When you're solving, you go backwards. So it's SADMEP. So the first thing I'm going to do, there's no addition or subtraction I can touch because that's in the parentheses. So I'm going to divide because I have that multiplication right there. Try and just get x by itself. So x plus 1 squared equals 25. Well, this is a perfect square, even if it doesn't look like it, because it's a number squared. And what is the square root of x plus 1 squared? X plus 1 equals plus or minus 5. Remember, we need to have two answers.
Wait, but you said we need to get x by itself, so what about the 1?
I'm not done yet. Very good, Justin. Minus 1, minus 1. So if I had positive 5 minus 1, x is 4.
Oh.
If I had negative 5 minus 1, x is negative 6.
I think I messed that up on the homework.
Well, you haven't done this yet.
I thought I had a couple of places where it would be. Oh, never mind. Sorry.
Okay. So then, see, this isn't so bad, right? So then let's do Oh, just like 1,000 problems.
boy.
No, I don't.
All of it.
Oh, great.
Two.
Every single one.
There may or may not have been days when I've changed your homework assignment based on your behavior in the class.
Oh yeah.
Like, because we're like being really noisy, add more.
I could
Or
add
the
more.
opposite.
You never know.
She could.
So, but like,
I am the monarch.
Well, you guys know that I gave you an extra few problems.
Okay. So then, trying to solve this one, I can see, oh, it's a perfect square already, and there's nothing even over there with it. So 2r minus 5 equals plus or minus 9. So 2r minus 5 equals positive 9. Splitting it up here just because I have more math to do. Don't want to get confused. Meaning I'm doing that for your sake. So 2r equals 14 because I add the 5 over here. R equals 7. 2r equals negative 4 because I add the positive 5. R equals negative 2.
Remember this from Algebra 1.
wait, for, number 27, is that, just, how'd you do that?
So number 27 says 2 rad 7 times rad 7. What's rad 7 times rad 7? This would be the square root of 49, but what is any square root times itself? No. Just the 7, right?
So then it's 14.
That's right.
Right, because it'd be the same as squaring it.
Yep,
And that's it.
that's it. So I'm looking for one where it's not even. All right. You have 5. This is number 63. 5 times x minus 7 squared equals 135. So divide both sides by 5. And I get that.
Oh.
Did he try to come in here or something?
Oh,
X minus 7 squared equals 27. Then I do the square root. And I get that x minus 7 equals the square root, that's right, plus or minus the square root of 27. Now, is there a part of 27 that I can take the square root of? Is there a perfect square that's a factor? 9. So what's the square root of 9? 3. And if I take out 9 from this number, what's left under there? 3. Yes. So, adding the 7 to both sides, x equals 7 plus or minus 3 rad 3. Totally
That's
legitimate,
the answer.
acceptable answer. Yes.
7 plus or minus 3 rad 3.
Right.
Which is the same as 3 times rad 3.
Yes. Which is
But
the same thing as the square root of
plus or
27.
minus. The plus or
No.
minus operation happens after the 7.
Right. It only happens to what I took the square root of. That's it. I did like 10 of your homework problems.
I like when we get to do the whole what is
The homework is
changing it right now?
posted on Google Classroom, and it's page 267, 19 through 50 all, 51 through 73 odd. But I did do a few of those for you, so you should be okay.
What was the second part after 1950 all?
51 through 73 odd.